I'm Ryan Clayton, field agronomist in south central Iowa, and I'd like to talk to you a little bit about Growing Point Agronomy's seeding rate efforts. You can see from the first slide we have here that Pioneer continues our largest precision ag-based farm research effort in the industry. With our Growing Point Agronomy trials, you get an illustration of the locations we have across the central business unit, showing and proving that just within a few minutes of each other, you can find multiple location data and drive the recommendations when it comes to our seeding rate information. When we think about seeding rates and the results we saw in 2014, we got to think a little bit about the growing season as well. You can see from this slide, I have 4 bullet points that kind of summarize the growing season. We had cool spring temperatures, we had record June rains, we had low stress during pollination, and we also had August and September late season cool temperatures and above average rainfall. So the high latitude season brought some challenges that certainly affected our seeding rate recommendations, but we also had record yields in some counties, and I think that's where the low stress during pollination factors in. You can see from this next slide an example of how the cool springs affected our seeding rates and our final plant populations. On this slide, we illustrate from 98 trials across southern Iowa how the final stand counts in the Growing Point Agronomy trials were affected by the cool periods we had throughout the early spring. As you can see from the individual growing degree unit chart below the planting date chart, it shows that anytime we had a 2 to 3 to 4 day stretch of cool temperatures, we saw an associated drop in final plant population from our original seeding rates. And that's illustrated very well with those 2 graphs, one on top of the other, showing specifically that when we got to late May and our growing degree units were up and we were getting more heat and more warmth, our final stand counts were reflected from that. The next slide is showing some results with our hybrid by yield level. We'll continue to present most of our seeding rate and population data in this manner moving forward, just like we have in the past. We see a huge response to seeding rates based off yield level. And in this example, you can see with this product that the lower yield levels, we saw a lower optimum population. And as we went up with higher yield levels, the population moves up the chart, closer to the 36,000. As we transition, one of the big additions to the 2014 data and how we'll present in 2015 and beyond is by looking at our results by soil. The 2-year data here showing hybrid by soil classification by seeding rate is a new example of how we're going to present this information to help our growers make specific seeding rate recommendations from farm to farm. You can see in this example with 993, we look at it with average well-drained soils as well as average poorly drained soils. So an example on that left chart of an average well-drained soil would be like a Sharpsburg soil, and an average poorly drained soil would be like a Canisteo. You can see how that single product responds differently in those 2 different environments. In an average well-drained soil, we see pushing the population to 34,000 to get the optimum yield, whereas in an average poorly drained soil, we can actually push that population even higher. So in a dry year like 2013, we held more water in that poorly drained soil. And in a year like 2014, that could probably be described because with the heavy rainfalls, we lost more stand like we illustrated before. The next slide is another example of our results hybrid by soil and by soil classification. Again, focusing on the poorly drained in this example, looking at a different family of P0987AMX. We look at how we can divide that out within the poorly drained soil classification in 3 different yield levels, below average, average, and above average. You can see from our example here, and I guess some examples, that first one would be a below average poorly drained would be an example like an Okoboji or a Luton soil. Your next chart would be an average poorly drained, a Canisteo or a Zook would be a good example. And your above average poorly drained would be like a Nicolette or a Webster. And you can see how we can classify our seeding rate recommendations based on these soil types. You can see in this example the below average poorly drained and the average poorly drained, we see a similar response with that 34,000 being our optimum seeding rate. When we get to the higher CSR or the higher, more productive soil or the above average poorly drained, the Nicolette Webster types, there we can see pushing it to 38,000 to get the maximum yields. The last question folks may have is where can we find this information? Where can we find the seeding rate data that we've generated from the last several years of Growing Point Agronomy trials? You can see from this slide an example of what we call our product profile sheets. These can be obtained by talking to your local sales rep or your Pioneer agronomist or Pioneer account manager as well. We suggest visiting with your local sales rep to get this information. You can select the products that you have scheduled for your farm, and they will come equipped with seeding rate recommendations.